So moving a little bit further into trigonometry, we're going to start solving right triangles using sine, cosine, and tangent. So we're going to try to apply what we learned earlier. Now, to try to remember, sine, cosine, and tangent, they have a little phrase, so, ka, toa. So stands for sine of an angle, theta, is equal to the opposite side over the hypotenuse. Ka says the cosine of an angle is equal to the adjacent over the hypotenuse. And then toa, tangent of an angle, is equal to the opposite over the adjacent, if you will. So to use sine to find the unknown parts of a right triangle, we have to know one acute angle, and we need to know the side opposite that known acute angle and the hypotenuse. We need to know at least two of those three pieces. So one of the acute angles, an opposite side, or the hypotenuse, that would be our little triangle of things. So once we know two of those three things, we just substitute into our formula. And again, we're going to be using, the SOHCAHTOA as a strategy. So if I look at this first example, find angle A to the nearest tenth of a degree, if A is equal to 7 and C is equal to 21. So to find angle A, notice that the 7 is opposite and the 21 is the hypotenuse. So I can use sine here. So the sine of angle A is going to equal the 7 over the 21. Now, what I can do is use inverse of this to actually find the angle. So to find the angle, we do the inverse of 7 over 21, and that'll actually find the angle. Now, since they're wanting degrees, I got to make sure my calculator is in the degree mode. So mode, it's still in degrees, so I'm okay there. So if I want to do the inverse sine of 7 over 21, we have the second sine there, and then we put the 7 divided by 21 inside there. Or you could also put a 1/3 in there. And that gives me 19.47. Since it said to the 10th of a degree, A is going to equal then, oops, I lost it there. So A was going to actually equal 19.5 degrees. So example 2 says find side A in triangle ABC. So again, notice how we have angle A this time. And notice how side A is opposite. And the 15 is the hypotenuse. So again, that fits into the category of sine. So the sine of the angle 53.5 degrees is going to equal the opposite side, which we don't know. That's going to be A over the hypotenuse, which is 15. Now, the easy way to do this is just make this a proportion. So put the sine of 53.5 over 1. And remember, we just cross multiply. So 1 times A is going to be A. So A is just going to equal 15 times the sine of 53.5 degrees. So remember, our mode is already in degrees, so we don't have to put that in the calculator. So all we got to do is put 15 sine and just put 53.5 in there. We don't have to actually put the degree symbol in there. It's understood to be degrees. And that'll give us then, and they don't say what to round to, but since these are all since the 15 is to the nearest whole number, I would probably say round A to the nearest whole number. So we'd say it's about 12. Now, remember, it cannot be bigger than 15 because 15 is the longest side. And notice that A is close to the same length as the hypotenuse. So it does seem like we got the right answer there. So if I want to find the hypotenuse in this example, notice how, again, the acute angle is 32. Notice how this is the opposite side. And here's the right angle over here. So this is the hypotenuse. So we can use sine of 32, and it's going to equal the 25 over the hypotenuse, which we don't know, and they're calling it t. So just put a t there. So if we solve this, we can cross multiply. So we're going to have t times the sine of 32 is equal to, try that again, that don't look like a 32. So the sine of 32 is going to equal 25. And then to get t by itself, we need to divide both sides by the sine of 32. So our math is going to be t equals this 25 divided by the sine of 32. So again, if you like to use the fraction button, you can. So alpha F1, number 1. So we have this 25 on the top and the sine of 32 on the bottom. And that'll find us our missing hypotenuse. So we get 47. And since the other side was 25, so let's just round to the nearest whole number, and that would just be 47 feet then. And so that makes sense there that, it looks like this looks much longer than the 25, so that 47 sounds reasonable. Again, the hypotenuse has to be the longer side anyway. Okay. So let's look at another example. Solve triangle DEF. One side and other parts besides the right angles are known. So like I said, we do know this is a right triangle because we do have a three-sided shape and there is a right triangle there. So we can use this SOHCAHTOA as our strategy. So let's just see what we know. So we know this acute angle here. So to solve the triangle, we're looking for these different sides. So they're looking for side D and side F, and also this angle up here, angle E. So one thing to pick up on is if this is a right triangle, the acute angles have to add up to 90 degrees. So to find angle E is going to be 90 minus 32.5. So that's one thing I need to find is angle E, the missing angle. So if I put 90 minus 32.5 into the calculator, that gives us 57.5. So remember, all three angles of a triangle have to add up to 90. Or I'm sorry, have to add up to 180. And since this is already 90, we know the other two angles have to be 90 as well. So I can just use this 90 minus 32.5 to get there. So 57.5 would be the missing angle. So now we need to find the missing sides. So if I'm trying to find side D, well, the only thing we know with respect to the 32.5 is we only know the adjacent side. So the E is the adjacent side. So if I'm trying to find D, that's going to be the opposite over the adjacent. Opposite over adjacent is going to be tangent. So if we use the tangent of 32.5, D is going to be the opposite, and the E is going to be the adjacent. So again, if I put the tangent of 32.5 over 1, I can cross multiply. So D is going to equal then 24 times 32.5. Sorry, 24 times the tangent of 32.5. So if I put 24 times the tangent 32.5 into the calculator, that'll give us the missing side D. Again, our calculator is already in degree mode, so this should work out just fine. So D is going to equal then, and since E is a whole number, let's just go ahead and round D to the nearest whole number, so that would be like 15. So then to find F, notice how F is the hypotenuse. So let's just keep with E. Notice how to find F, that's going to be the adjacent over the hypotenuse. That would be cosine. So the cosine of 32.5 is going to equal, again, the adjacent is the 24, and we don't know the hypotenuse, which is F. But again, if I put this over 1, I can cross multiply. So this is going to give me f times the cosine of 32.5 is equal to 24. So to solve for f, we got to divide both sides by 32.5. So f is going to equal then 24 divided by the cosine of 32.5. So if I do that math, so 24 divided by the cosine of 32.5. You can also do it that way. Don't have to actually use the fraction key. So that's going to give me, f is going to equal then about 28. And again, we're all in inches here. So that's 28 inches. And then D was 15 inches. And the missing angle was 57.5. That would be the three missing pieces to this. So again, if I want to use cosine, again, I didn't have to use cosine there, but I did. So we can kind of continue on here for a few more examples. To find cosine, to use cosine, we do need to know two of the three things. Again, we need to know an acute angle, the adjacent side, and the hypotenuse. So remember, the cosine of an angle is going to be the adjacent over the hypotenuse. So remember, we have SOHCAHTOA. Notice that stands for the cosine of an angle is equal to the adjacent over the hypotenuse. So if I'm looking to find the angle A, notice how the 1.9 is the adjacent side and the 3.6 is the hypotenuse. So that would be cosine. So the cosine of angle A is going to equal this 1.9 over this 3.6. Now remember, to find the angle, we have to actually use the inverse. So the inverse cosine of 1.9 over 3.6 will give me the angle. So to get the inverse, we got to use the second button, inverse cosine. And then we have this 1.9 divided by 3.6. If we enter, that'll give us the angle. And looks like the angles we could round to the nearest tenths place is what they've been doing. So angle A would equal then 58.1 degrees. Now, in example 6, if we want to find side B, notice how if this is the acute angle given, notice that side B is the adjacent, and the 42 that's given is the hypotenuse. So that tells us that we are going to use a cosine. So the cosine of 19.5 is going to equal the adjacent, which we don't know is B, and the hypotenuse is 42. So again, if I put this cosine over 1, we can treat this as a proportion and cross multiply. 1 times B is B. So all I got to do is figure out is what's 42 times the cosine of 19.5, and that'll give us the length of B. So we have 42 times the cosine of 19.5. Hit enter, and that'll give us then the length of B, which is going to be, we'll call that 40, 42 or 40 centimeters for B. Since the hypotenuse is rounded to the nearest whole number, we'll round that to the nearest whole number. So if I want to find side T, notice that here's the right angle up here. So that means this is the hypotenuse over here. And here's the adjacent angle. I'm sorry, this is the acute angle. So with respect to the acute angle, this would be, side R would be the opposite. And over here, well, actually, we're talking about R. This would be the adjacent. So with respect to what we're looking for is we're given the adjacent, we're given the angle, and we're looking for the hypotenuse. So that tells me that this is going to be a cosine problem. So the cosine of the 55 degrees is going to equal then the adjacent, which is the 15, over the hypotenuse, which is the T. So again, if we cross multiply, we're going to have t cosine of 55 is equal to this 15. So t is going to equal then this 15 over this cosine of 55. So you kind of start to see a pattern, you know, the t and the cosine of 55 are basically swapping places in that sense. So anyway, we end up with then 15 divided by the cosine of 55, and that'll give us the length of t, which is 26, and this will be 26 meters. So again, since the adjacent was in a whole number, I'm going to go ahead and round this to the nearest whole number as well, 26 meters. So if we look at tangent, remember tangent is going to be the TOA. So that's going to be the tangent of an angle, which they use theta, is going to equal the opposite over the adjacent. So that's kind of where they're coming up with this. So we can kind of memorize it by using SOHCAHTOA. SOHCAHTOA. It's almost like an Indian name. So anyway, let's look at this example where angle A, we don't know what angle A is, but notice how the 14 is opposite and the 16 is adjacent. And over here, notice here's the right angle. So this would be the hypotenuse over here. We don't have anything on that. So since we know something about the opposite and the adjacent, that means this is a tangent equation. So the tangent of angle A is going to equal the 14 over the 16. And remember, to find the angle, you have to actually use inverse. So inverse tangent of 14 over 16 will give us our angle. So second tangent gives us our inverse tangent, and then we can just do 14 divided by 16. And that's going to give us then, and we can round that to the nearest tenth. So angle A would be 41.2 degrees. So if I'm looking for side A, so here's angle A, so side A is going to be the opposite of it. Here's the right angle, so this is going to be side C, or that's going to be the hypotenuse. If this is angle B, then this is going to be side B over here. So anyway, we do have an acute angle given. So A is going to be opposite, and the 6 is going to be the adjacent. So remember, that's tangent. Remember, TOA. TOA is going to be tangent of an angle is going to equal the opposite over the adjacent. So that's going to work for us. So again, they gave us the angle, so the tangent of 44.5 degrees is going to equal then this A over the 6. So we pick up on it, this is going to be A equals 6 times, because remember this is going to be over 1. So this is going to be 6 times the tangent of 44.5 degrees. So let's go ahead and clear all this off here and get a fresh screen. 6 times then tangent of 44.5. Because our mode is already in degrees. So that gives us then A is going to be about 6. So that's going to be about 6 centimeters. And that's pretty accurate because, 44.5 degrees is like a 45-degree angle. And remember, in a 45-degree angle, the legs would be the same length. So if we have a 6 over there, that would be a 6 as well. So if we want to find side B in this example, notice how, again, we have the acute angle here. So this is going to be the opposite. And again, this is the right angle up here. This is the right angle over here. So this has got to be the hypotenuse, which means this has got to be the adjacent. So what we're looking for is the adjacent. So if the opposite is given and we're looking for the adjacent, that is a tangent problem. So the tangent of 19 degrees is going to equal 10 over B. So remember, what we're picking up on is these two places are just going to switch places here. So B is really just going to equal 10 over the tangent of 19 degrees is what that turns into. So I can kind of pick up on a pattern there, just swap the rows of those two, and that'll get us there. So 10 divided by tangent of 19 gives me then 29. So we're going to the nearest whole number. So B would equal then just 29 centimeters. So our last example we have going on here is an application in construction. So a surveyor locates 2 points on a steel column so that it can be set plumb, in other words, perpendicular to the horizon. If the angle of elevation is 15 degrees and the surveyor's transit is 175 feet from the column, find the distance from the transit, which they call point A, to the upper point, point B, on the column. Again, A is a surveying instrument used for measuring angles. So, over here, you kind of see that this guy is actually using a transit. So there's several things involved here. But a transit is a way to kind of measure things with respect to angles and things like that. Like, so a lot of the stuff is already digitized, so he probably doesn't have to do any calculations. He probably does it all on its own these days. But back in those days, you had to jot down the information and then you had to do your calculations. So, excuse me. They go ahead and give us the picture here that we have 2 points on a column. And we know that the elevation using the transit is going to be this 15-degree elevation. What they want to know is how far is it from point A to point B, this distance here. So notice that if we use SOHCAHTOA, let's see which trig function actually fits the information given. So we do have a given angle, the 15 degrees. The 175 would be adjacent to it. Here's the right angle over here. So that means we're looking for the hypotenuse. That's going to be the unknown. And they even say what's the hypotenuse. So if we have adjacent and hypotenuse, this is going to be the cosine function. So the cosine of the angle A, which was 15 degrees, is got to equal the adjacent, which is the 175, over the hypotenuse, which is going to be little c, since angle C was over here. Remember, to solve this, we could create a proportion, but notice how all we really got to do is switch the rows of the c and the cosine of 15. So c equals then 175 over the cosine of 15, and that'll give us our hypotenuse. So it should be longer than 175 because the hypotenuse is the longest side here. So if I type in 175 divided by cosine of 15, hit enter, and yeah, we do get a number bigger than that. And again, since they had a nearest whole number there, we can round that to this whole number. So we'd have 181 feet would be our answer if we round to the nearest whole number, because the 10th place is a 1. So that means we just round back down to the 181. So this is where this kind of leads to, is there's a lot of applications with trigonometry in the real world. So this just gets you exposed to that a little bit. Take care.